The Cassini Space Probe, Saturn's Ringmaster. What would Saturn be without its beautiful system of rings? Over the past 13 years, the Cassini Space Probe has shown us just how complex and dynamic the rings truly are. The 20-year mission came to an end on September 15, 2017, when the probe made its final destructive plunge into Saturn. As part of its grand finale, the Cassini probe flew closer to the rings than ever before, first grazing the outermost edges of the rings before taking the risky leap of diving through the gap between the rings and the planet. One of the biggest surprises was that it's quite empty between this gap. This is very different to when Cassini was bombarded by hundreds of dust particles per second, as it moved past the outer rings late 2016. But it meant good news for the mission, as its final stage had a better chance for success if there was less material in the way. During a ring dive that August, instead of orientating Cassini so that it flew antenna first through the gap, thus offering it more protection, the spacecraft was turned around, allowing it to capture a fantastic view of the rings as it dived past them. Over the centuries, as Saturn's rings have been observed in finer detail, they have been broken into discrete sections. They are named alphabetically in order of discovery, which means from the innermost to outermost, the order is D, C, B, A, F, G, and E, respectively. Saturn's innermost ring, D, is much less dense and therefore fainter than its neighboring ring, C. By comparing Cassini's images of the D ring with its original discovery image from Voyager in 1980, it's possible to see changes in the ring over a relatively short period of time. In the Voyager image, 3 relatively bright arcs can be seen in the D ring. The bright arc in the lower left frame is the C ring. Most dramatically, the central and brightest arc has faded markedly and moved 200 kilometers closer to Saturn. The arc no longer lines up with the Voyager image. We know that the rings are mostly made of ice, but it's not clear how they formed or even how old they are. The fact that they are still bright rather than just coated in dust suggests a young age, perhaps just 100 million years old, thus placing their formation in the time of the dinosaurs. For Saturn's outermost ring, E, the source is pretty clear. The moon Enceladus orbits within this ring, and Cassini observations have directly traced features in the ring back to geysers erupting from Enceladus's surface. While in the faint F ring, the moon Prometheus creates streamer channels, drawing material out of the ring. Prometheus interacts with the ring once every orbit, when it reaches the point that it takes it furthest away from Saturn and closest to the F ring. As Prometheus orbits faster than the ring material, a new streamer is created that is ahead of the old one with every orbit. Cassini spotted signs of a potential new moonlet forming on the very edge of Saturn's bright A ring. The newly formed object is probably less than a kilometer across, but being able to see such a process in action was a complete surprise for the Cassini scientists. This supports a theory that, long ago, Saturn's rings could have been much more massive and capable of producing some of the moons that exist today. It also potentially provides insight into how the planets of the solar system formed, emerging out of the accretion disk that once orbited the young sun. Cassini has certainly achieved its mission objectives to explore Saturn, its atmosphere, magnetosphere, and rings, and to study its moons, particularly Titan. So much has been learned, including the ability to gaze with wonder and awe at the amazing solar system we live in. Be sure to subscribe for more Space Rewind, and tell us in the comments what you would like to see next in an upcoming video.